Welcome to Mini Tutorials in Spectroscopy. Let's talk about dimensional analysis. Dimensional analysis involves identifying fundamental dimensions and units of measure and tracking these dimensions as calculations or comparisons are performed. Fundamental dimensions are properties such as length, mass, time, and electric charge, and most fundamental dimensions can be measured in a number of different units. In spectroscopy, in fact in the physical sciences in general, it is often necessary to convert between units of measure. We do this by employing the rules of algebra. Some cases of unit conversion are so common that we know them by rote. How many inches are in a foot? How many seconds are in a minute? In many cases, we have to actively consider conversion factors. For example, how many seconds are in 2 hours? We know that there are 60 minutes in 1 hour, and that there are 60 seconds in 1 minute, so taking the product of these and cancelling units allows us to calculate that there are 7,200 seconds in 2 hours. What about milliseconds? Here we can use the conversion factor of 1,000 milliseconds in 1 second. And now we see that there are 7.2 million milliseconds in 2 hours. Let's take the example of light with a wave number of 25,000 reciprocal centimeters and calculate its wavelength in nanometers. First, it is important that we know how the dimensions of wavelength and wave number relate. We can see by the units that they must be inversely proportional. But if we calculate 1 over 25,000 reciprocal centimeters, we arrive at an answer in units of centimeters. So we still need to employ conversion factors to find the answer in our desired units of nanometers. Now we see that a wave number of 25,000 reciprocal centimeters corresponds to a wavelength of 400 nanometers. We can conduct dimensional analysis to gain some confidence in our answer. Including our conversion factor yields units of nanometers on both sides of the equation. If instead we would like to convert between wave number and energy, we have to employ Planck's relation. Recalling that the speed of light is a product of its wavelength and frequency, and that the wavelength and wave number are inversely proportional, allows us to rewrite Planck's relation in terms of wave number. Dimensional analysis shows that our calculation will yield an answer in joules. Note the conversion factor of 100 centimeters per meter that has been included. To obtain an answer with units of electron volts, we have to include another conversion factor. Now we see that 25,000 reciprocal centimeters corresponds to an energy of 3.1 electron volts. I hope that you have found this mini tutorial on dimensional analysis useful. See you next time.